I got this great question on mean and standard deviation of sample proportions. Um, so this would be a question. A safety officer of a mining company takes a simple random survey of 500 employees and finds that 15% of the sampled employees wear contact lenses. The officer may take several more samples like this. Suppose that really 12% of the approximately 34,000 employees in the company um, wear contact lenses. What are the mean and standard deviation of the sample distribution and the proportion of employees who wear them? So the the student thought that the mean of the sample proportion would be 0.15 because that's what the sample told us, right? And samples definitely do have a relationship with the standard with the sampling distribution, but it's actually a much more complex story. And I love these kind of questions because they really get at the concept of everything. So here's what the student says. For example, how come in this question you need to use the percentage of the entire population, the 12%, instead of the percentage of the sample population, 0.15? It's confusing because it's asking you for the mean and standard deviation of the sampling distribution. And the 0.15 is from a sample. But remember what a sampling distribution is. So, you this is for proportion, right? You have some kind of survey question like, do you like peanut butter? And the whole population, right? Just you go through and you ask a bunch of people and you get yeses and nos. Okay. Now, a sample from that population would be just a subset of the whole population. Like this is a small enough population where you can actually ask everybody. It's like going around your house and asking everybody in the house what movie do you want to watch this movie tonight? They can either say yes or no. But in general, we're usually interested in populations that are really too big to get the whole population, to collect data on the whole population. But it helps us, in this smaller example, it helps us to think about what a sampling distribution is. So a sample would just be some kind of subset. And usually we set the sample size to be the same. So I've taken 3 different samples of four people each. And you'll see that the sample, in this one, 75% of the yeses. In sample 2, 75% of the are yeses. And notice that, you don't necessarily have to have, somebody can be part of two different samples. Okay. And then in sample 3, here only 50% of them are yeses. So your samples are actually going to vary in terms of what proportion of the people like peanut butter. Okay. So back to our situation here, the safety officers are taking samples and they find in the first one that 15% wear contact lenses, and they're going to take another sample of 500 employees and they might find out that, only 10% wear contact lenses in that sample. So you get a whole bunch of different samples, right? And what the sample distribution is, got a neat little tool that will show you. So if I take one sample, right, the population proportion is 0.1, 12%, right? Oops, sorry. Let me get rid of that. I think our sample size was 500. Okay, so I'm getting rid of this. Now let's do it one time. So I take one sample of 500 people, and I found that 13.2% of them wear contact lenses, right? And in my sampling distribution, right, I'm now plotting one single point. Okay. Now I do another one, right? This time the proportion is 14%. Okay. And I plot another little point. And it goes on and on and on and on and on, right? We can do this thousands of times. And what happens is that the mean of this sampling distribution ends up being converging on the population proportion. And so that's why it's the population proportion that really tells you about the sample distribution and not a specific sample. So I hope that helps.